This is section 5.5, example 7. Equations containing variables in logarithmic expressions such as log base 2 of x equals 4 or log of x plus 3 equals 1 are called logarithmic equations. To solve equations algebraically, we can first try to get it as a single log, or we can write an equivalent exponential equation. So let's look at some examples of doing that. So for the first one, I'm going to take it out of log form and put it in exponential form. And to do that, remember that you start with the base. The base in this case is 2. So 2 to the power, which is away from the 2, which is the fourth, equals x. And 2 to the fourth power, well, that's 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 equals x, and that's the answer. All right, for B, we've got 3 is the base to the number that's away from it. So the number that's away from it is the negative 2 power equals x. The negative turns this into 1 over 3 squared. It always turns it into a fraction. And 1 over 3 squared is 1 over 9 equals x, and that's the answer. All right, now C, you needed to use your properties. Remember that this is actually the product rule. So the product rule here says that you're going to bring this back together as log of x times x plus 3 equals 1. Now also remember that this logarithm has a base, and that base is invisible. The base is actually base 10 here. So when I take it and put it in exponential form, I have base 10 to the number that's away from it, power, which is 1. So 10 to the first power equals x times x plus 3. Now I'm going to distribute the x. So I get 10 equals x squared plus 3x. I subtract 10 from both sides, and I get 0 equals x squared plus 3x minus 10. Now I have to factor that. That factors into x plus 5 times x minus 2. So x equals a negative 5, or x equals 2. Now with logarithms, you can also pick up those things called extraneous solutions. So you want to check these. The check on these are very easy though, because remember that you can never take the log of a negative number. So if I go back up to the beginning and I put in that negative 5, I would have log of negative 5, and you can't take the log of a negative 5. So this first one, the negative 5, is an extraneous solution. If we put in the 2, that's going to give us log of 2 plus log of 5. We can do both of those. So x equals 2 is the only solution. And the last example, since this is subtraction, we're going to make it a quotient. So we get ln of 4x plus 6 over x plus 5 equals ln of x. Now, since there's ln's on both sides, remember that if the bases are the same, both of these bases are e, then the arguments, they're called, have to be the same. So our two arguments are 4x plus 6 over x plus 5 has to equal x. And I'll put that x over 1 and cross multiply. So when I cross multiply, I get 4x plus 6 equals x squared plus 5x. Now I'm going to subtract 4x and subtract 6 from both sides. So I get x squared. 5x minus 4x gives me x. And then I've got a negative 6. And that factors into x plus 3 times x minus 2. So that gives me my two solutions, which are x equals a negative 3 and x equals a positive 2. Now we want to check those because there might be some extraneous solutions. So if we put the negative 3 in, negative 3 times, well, over here, we would just have ln of a negative 3. You cannot take a log of any negative number, so that's not a viable solution. If we put the 2 in, we'd have ln of 2, ln of 7, and ln of 14, so that x equals 2 works, and that's the solution.